Let's take a look at some of the features of the string class in Java and processing string data. Now, in our work so far this semester, we've used string data throughout the course, but we really haven't talked much about the details of how strings are stored in memory or how they are actually set up. The string class is a class, and so objects that contain string data actually are represented with two private data members. There is an integer data member for the length of the string, the number of characters in the string, and then there is also an array of characters to keep track of the individual contents, each character of the string. So for example, if we set up a string with the actual value hello with an exclamation point after it, there are actually 6 characters in that string because of you have to count the punctuation, and so the object would be set up this way with the length component being 6 and the contents, each individual character being stored in a separate element of the array, and as with all arrays, the first position of the array is position number 0. Okay, let's move on. And just a quick thing to mention is that the long version would be calling the new operator with the name of the class like you would do for any type of object in Java. However, with strings, Java gives us a shortcut. We can just specify the contents and it makes a new object this way. So we're good with that. And we've also seen the plus operator for concatenation. We know that it takes 2 strings and joins them back to back with no intervening spaces. So the operation of this particular statement, 1 plus 2, would take those 2 strings, join them together, and so 3 would contain superfun. So we've seen the string concatenation operation. And one thing that you should notice is that strings are not changed by being concatenated. The original strings 1 and 2 would be unaffected. And that's a sort of a general rule that applies to any string operation in Java. And the term we use, the programming term we use, is we say that strings are immutable in Java. Immutable means cannot be changed once they are set up. So any string operation will result in a new string that we can use for whatever purposes. But the strings that we operated upon, we used for the operation, are going to be unchanged. So one of the things to use the string class is you need to know what are the methods that are in the string class. And so there are many methods that are defined. Each of them does not change the string being operated on, but it results in a new string that can be used for further processing. So let's take a look at some of the string operations. Maybe the simplest one is a method that will return the length of the string. And so it returns the integer value with no parameters. And so if I would store the sentence, "This is cool," with an exclamation point after it in sample, okay, there are 13 characters there because you have to count the intervening spaces between words and the punctuation and so on. And so this example would print the value 13. In the Java console, calling the length method for the string sample. Excuse me. I've set up a NetBeans program with this. Instead of being printed in the Java console, it's going to be printed in a text area on the screen. And so if I run this code, and I get the answer down here. So the value sample.length is what's printed in the output area, and so we have 13 as the value that is printed. Okay. Now, another of the string methods is a simple one. It's called toUpperCase, and the toUpperCase method accepts no parameters and returns a string value. And so once again, the idea is the original string is unchanged, but the new string that's formed by this would be a copy of the old string with all lowercase letters converted to their uppercase equivalent. So we go character by character through the string. If a character is not a lowercase letter, it's unchanged in the copy, but if it is a lowercase letter, it's replaced by the uppercase version of that letter. So in this case, you'll see that if I had a string called sample and then I called toUpperCase on that, stored it in another string called new one would be all the same contents as sample, except that it would be all capitalized. So let's actually do that. Let's type in that method in NetBeans and see it work in action. Okay, so this is an example of the toUpperCase method. And I cannot redefine, once sample has been declared in this method, I can't redefine it. So get rid of that. New one is sample.toUpperCase. Okay, and then we'll print sample and new one on consecutive lines in the text area. Okay, if I run this program, and you'll see that sample is unchanged. So after calling to uppercase on sample, then I print sample. Sample is the same as it was, upper and lowercase letters, but the result of that, which was stored in new one is the same string with all uppercase letters. So strings are immutable. Okay, another related thing, very similar to uppercase, there is a to lowercase method. To lowercase, and okay, so let's just see what happens if I call that. Once again, I cannot redefine the same variable in the same method, so I take out that string there, and now I think this will work. Oh, yeah, to lowercase. Hopefully this will work. And what you should see is that in the to lowercase example, there is only one uppercase letter, which is the capital T, and notice that it's replaced by a lowercase t in the result. Okay. We have a web page that's set up with definitions or descriptions of lots of string methods. We're going to see this in Lab 11 and our work here at the end of the semester. Now, one thing I wanted to mention, though, about the immutability of strings, what happens if, notice that the original string was unchanged by calling to uppercase. If you wanted to change the contents of a string to be the result of a string method, what would you do if you wanted to add 10 to the current contents of an integer variable x? You would say something like x equals x plus 10. Okay, well, same kind of an idea here. We would use the same variable or string object on both left and right hand sides of the assignment operator. So in this case, if I take the sample and apply to uppercase to it and then store that result back in sample, the old version of sample is replaced by this new result here, and so sample would be converted to all uppercase. So let's take a look at that in NetBeans. Oh, if I went up here and got rid of new one and I said sample, it'd be nice to have my hands in the right place, equals sample dot to uppercase. Okay, and then I got to get rid of this new one, and I have to make this into a string here so it runs. And it'd be nice if I didn't have a capital T there. Okay, so what I'm doing is I'm taking sample.toUppercase, storing that back in sample. So now the version, you'll see that sample here was converted to all capital letters. Okay. And if I don't do this line here, and I run it, notice that sample was all capital letters here, and then it's converted to all lowercase in that second example. Okay, let me show you one other example real quick. And let's see here. If I wanted to say, let's see, what do I call it? This is school. All right, the character at method. Okay, here's char at. It accepts an integer parameter and returns a character, which is the character at that particular index position in the string. So, if I have this is cool, then what I could say is the character in position 3 is nuts, sorry, sample.charAt and position 3. Okay. Oh, nuts. Sorry for the typo there. Let's do this and say sample so you can see it. And when I run, okay, notice that position 3, now the position 0 is the first position. So it's 0, 1, 2, 3. So the character in position 3 is an S. Okay, so that's just an example of some of the string class methods in Java.